Hey pre-AP, here's another helpful video. This time it's on water. So have your pen, your highlighter, so you can annotate your notes, highlight what's important, and write some examples down to help you remember these concepts easier. So please know, water and life, where it says numeral number 1, we need to know that water, it's mainly going to be found in your cells. And it makes up 70 to 95% of an organism's body. Now this is for all life forms on Earth. This is plants, fungi, bacteria, us, little puppy dogs. Everything is made of 70 to 90% water. So what's so great about water, and why are we even talking about water? It's not just that liquid in your Dasani bottle that you drink after PE because you're exhausted and you need some refreshing. So water is a polar molecule. Why is it polar? Because it has a positive and a negative end. Now, where in the world does that positive and negative end go? Why do I have to know that? So, please draw this molecule out to the side of your paper somewhere. It's kind of like an upside down Mickey Mouse head. Put your 2 hydrogens. Kind of make them a circle. Then make it one big old circle it connects to. That's oxygen. Now, oxygen is slightly negative. Hydrogen is positive. Remember, oxygen's negative because if we look about the size of the molecules, know that oxygen is slightly negative because it has more protons than hydrogen. Now, because it has more protons, it means it has a larger atomic mass. Means it has more matter inside of it. Hydrogen, on the other hand, well, poor little old hydrogen, he only has 1 proton. So in size, compared to oxygen, he's a little bitty fella. So he's going to be positive because he would rather not fight with oxygen and just kind of share those electrons with him. So, water's polarity, because it's polar, that oxygen's negative, that hydrogen's positive. You can have hydrogen bonds form very easily. Remember, think about from today. Hydrogen bonds, are those weak or are they strong? So this polarity makes it possible for water to conduct electricity. Put out beside where it says has able to conduct electricity, put you an example out there. That is my phrase for don't drop your hairdryer in the tub. This is why if it's lightning outside or coming a thunderstorm, they tell you don't get in the shower, because water is a great conductor for electricity. This is why you have hydroelectric plants down at the dam in Gunnersville. They use water because it carries electricity so well. It makes all of our lights and appliances come on. So thank you, water, for being electrifying. Alright, and please know that the polarity, because it's slightly positive and negative, it allows a single water molecule to bind to 4 others at the same time. Ooh, let's draw that, shall we? So here's one water molecule. You've got your little fellas here. Remember what bond holds your oxygen to your hydrogen? Oh, wow, look. Polar covalent bond. Think about what we did today. Oh, shaking that really hard paper clamp. Can't get it loose. That's a very strong bond. Now let's draw you a little hydrogen bond. Those are going to be little dashes. Now that hydrogen, it's going to connect to an oxygen of another water molecule. Make your positives. Ooh, then this hydrogen is going to connect to another oxygen molecule. And then this oxygen up here is going to connect to a hydrogen of another water molecule. So remember, it kind of looks like an upside down Mickey Mouse. They also say that it is a upside down V shape. So little water molecules between a single water molecule connecting, this is one water molecule, this guy right here, between your hydrogen and your oxygen, right here and right here. That's covalent bonding. That's very strong. But if you're connecting two water molecules together, like this one's one, this one's two, this is going to be hydrogen bonding, because you want to be able to break those hydrogen bonds to be able to conduct heat, to carry electricity, things like that. So, please, let's talk about how it can bond to 4 water molecules again. This little fellow right here, that's a great picture. It's a beautiful picture. This picture, it's on the PowerPoint, it's on Edmodo. You can go back and look at it again. Cohesion. Out beside cohesion, we're going to make a little note. So put your example. This is how I remember cohesion. Co means working together. So this is like your co-workers. One day you're going to have a job. You're going to have people you work with. Those are your co-workers. You work together to get your task done. Sometimes you work in partners or in a group. Those are your co-workers. You work together. So please underline or highlight that this means that water molecules bonding to other water molecules. And remember, the reason they do this and it's possible is because of that hydrogen bond. And please make a note. This is how water moves up a plant. So if you're a cute little plant, make you a flower. Your water is going to be able to travel up the stem of your plant from its roots down here. It's going to be able to travel up, go to your leaves, go up your stem, nourish the flower. That's how it works. Those water molecules have to stick together, work together to climb up the plant and give the plant water. So again, there we go. This cohesion of water molecules, go ahead, put this out beside there. Transpiration. We're going to do a lab with transpiration, so please put that out beside there where it says about plants. Transpiration is really important. We're going to do something with celery. Ooh. So adhesion. Know that it's water molecules bonding to something other than water molecules. This would be your example. Make yourself an example again. This would be putting salt in water. Look at all these water molecules. They are surrounding this big old salt molecule. And what it's going to do is that water is going to get that sodium by itself. It's going to want to get that chlorine by itself. That's how it's breaking down the water. Think about it. Which atoms of the water are attracted to the positive sodium? Ooh, look, it's those really big red fellas. That's oxygen. So remember, this is like magnets. Negative attracts positive. They do. But the chlorine, which one, the hydrogen or the oxygen? See those little white dots? They're attracted to the chlorine, so it's got to be hydrogen. Opposites attract. Surface tension. This is one of my favorite things. This is why I gave you some links on Edmodo on this PowerPoint. You can go watch these. You can watch the water walking lizard. This one's my favorite one, though. Your example for this is going to be belly flops. This is what makes belly flops possible. Whenever I taught swimming lessons and little kids would try to dive, they wouldn't position themselves correctly on the diving board, and they would go splat on top of the water. They'd come up, they'd have a red belly, and I'd ask them, "Are you okay, so-and-so?" And they'd say, "My tummy hurts. I did a belly flop." So why do you have belly flops? Why does it hurt your stomach if you slap the water really hard? Know that it's because it's the linking together of water molecules on the surface of a body of water. Those water molecules line up in cohesion, and they actually form kind of a film on top of the water. It's almost like a protective barrier. And remember, it's made possible because of hydrogen bonds. They link up. It's relatively, remember, it's a weak bond, so think about it. Whenever you splat the water, you break those hydrogen bonds. But there's enough of that on the surface that it kind of hurts you a little bit there. So belly flops, or you could put your example as another one as water walking lizard. Please know that water helps temperature regulation in organisms on the earth. Remember from elementary school, water comes in 3 states: solid, liquid, and gas. Think about where it comes in solids, where it comes in liquids, and where it comes in gases. Think about that for a minute. Glaciers, oceans, lakes, humidity. So know that water is a huge heat piggy bank. It stores a lot of heat because the sun, it's just a big old ball of gas that radiates heat. And to keep us from burning up and turning into little bitty burnt people biscuits, that water in the oceans and lakes and rivers and streams take all that heat in for us. And remember, the only reason that's made possible is because of those weak little cute hydrogen bonds. Know that it takes a tremendous amount of energy to break all 4 hydrogen bonds at once. Because remember, you can have one water molecule can connect and bond by hydrogen bonds to 4 other water molecules. And it takes a lot of energy to break those up to turn that liquid to a gas. It also takes a lot of energy to take that liquid to a solid too. No letter F where it says kinetic energy terms. You know that heat, all that is the total amount of kinetic energy. Temperature, it's the intensity of the heat in a substance as molecules move. So one of your examples I gave you was ice cubes in cold drinks. Remember that if you want to boil in your water, you got to be 100 degrees Celsius. You want to freeze, you got to be 0 degrees Celsius. You got to be in between 0 and 100 to be liquid. So solid. Woo, that's so wrong. Oh my goodness. I'm looking at the other one. This is whenever it's going to turn from a gas, whenever you boil it. This one is going to be a solid whenever you freeze it, like the ice cubes in your freezer. Heat, look at that stove eye. Don't touch it. Temperature, ice versus movement of water. Think about if you look at those 2 pictures, which one, liquid or the solid ice, is going to have more kinetic energy, going to move around a lot more? Please say liquid. Evaporative cooling. This is one of the other really cool things about water. Water can take heat away from your body, just like Hank talks about in Crash Course Biology. Because this guy is sweating, let's change our color to blue. He's sweating. You can tell he's sweating. He's just sweating everywhere. His shirt's, just wringing with sweat. Because he's burning up. The water molecules on his skin are going to attach to the heat on his body and take it away, and it's going to evaporate, taking the heat with it. This is going to help him cool down and feel a little bit better. So know that it's putting heat energy into water, causing it to evaporate and carry the heat away from the body, thus providing a cooling of the organism and all the energy leaves. But if you look at letter B, as wind increases, the effect of cooling by carrying the water vapor away from the water. So if the wind's blowing, it's going to help carry that heat and that water away from your body quicker. But if you live in the deep south, remember, we deal with humidity. All humidity is water vapor in the air. This is why in the summertime we never cool off, ever. Because humidity decreases the effect of carrying that heat and that water off of our skin. The water is in the atmosphere, in the air, making the air kind of heavy. I say that we're semi-aquatic people down here in the south. We breathe water, literally. Water vapor in the air. And then remember, water expands whenever it freezes. Alright, so that's all for this video. If it's too big, it won't upload, so I'm going to stop here. Go ahead, look at the back of part 2. We've kind of talked about this a little bit. I'm going to go over it in the next video. So I hope this was helpful. Please remember to go back if you didn't annotate things, and annotate things, please, so we can go through this and demonstrate it in an activity and not have to stand and talk about it.